Let's talk about quantum number two. Quantum number two is referred to as the angular momentum quantum number. And so here's where we're at. So we are looking at that the model has energy levels where electrons can be found. Those energy levels have sublevels, and those sublevels have orbitals within those sublevels that electrons are found in. So, again, if we go back to my apartment analogy, what this really means for us is that my apartment has floors, which our analogy here is energy levels. And then there are specific apartments on those floors. And so my apartments are actually represented by letters in my quantum numbers. They are S, P, D, and F. Okay, so even though we talk about quantum numbers, obviously the sublevels are not represented by quantum numbers. And then if I open a particular door to an apartment, there are rooms. So those rooms would be my orbitals. All right, so let's take a look at these sublevels and let's look at these orbitals. All right. So if I'm in sublevel S, we refer to these as S orbitals. The the letters of the orbitals help us hopefully to identify the shape of the orbital. So the orbitals within S are spherical in shape. And so in my picture here, I've actually shown the S orbital in three different energy levels. So the first energy level, the second, and the third. We can see that as you move from one energy level to the next, that the size of the orbital becomes larger. And the other thing to keep in mind is that as you move from one energy level to the next, the energy is also going to increase. So 2s then would have more energy than 1s. Right. So if I'm looking at the S sublevel, the S sublevel just has one orbital, and that's what we see in this picture. All right, the next type sublevel is P, and so the orbitals within P have a dumbbell shape. And if I look at this picture, notice that the number in front of P is all the same. So all of these are found in the second energy level. And what makes them different is the axis in which that orbital would lie along. And so if we're talking about the P sublevel, we can see that there are three orbitals. One that lies along the x-axis, one that lies along y, and one that lies along z. All right, the third sublevel would be D. And so the orbitals in D have what we call a double dumbbell shape. And again, all of these orbitals that are in the picture for D all are in the same energy level. They are just along a different axis in space. And so if we're talking about the D sublevel, I can see that there are 5 orbitals. All right, and then the last sublevel orbitals to look at is F. The orbitals in F have a flower shape. And these, again, are all of the F orbitals that would be in one energy level. So if we're talking about an F sublevel, then there are 7 orbitals. Right. So it's really important when we're discussing quantum numbers that you're looking for patterns. So the pattern that we hopefully see here is that the number of orbitals within a sublevel increases by an odd number, starting with 1. All right. Now, not only do we want to look for patterns, but we also want to look for relationships. So the number of sublevels is equal to the principal quantum number, which we talked about in the last video, which is the energy level. So what this means for us, for example, is if n is equal to 1, only one sublevel would be allowed. So when we name sublevels, we do so using the energy level. So we were in energy level 1 because that's what n means. And we go in terms of energy. So S has the lowest. So there would be a 1s. That would be the one sublevel that's allowed. If n is equal to 2, then only 2 sublevels would be allowed. And so, again, we use the energy level, which is 2, and the lowest energy sublevel, which would be S. And the second one would be a 2. And then the next sublevel in terms of energy would be P. So this would have a 2S and a 2P. If n is equal to 3, then only 3 sublevels are allowed. And so again, we would use the energy level, which is 3, and the lowest sublevel is S. Then we would have 3P, and then you would have the next sublevel in terms of energy, which is D. So then we have a 3D. And then if n is equal to 4, only 4 sublevels would be allowed. So we would have a 4S, a 4P, a 4D, and a 4F. Now, it also hypothetically means that the 5th energy level could have 5, and the 6th energy level could have 6, and the 7th energy level could have 7. However, it would be hypothetically speaking what the 5th, 6th, and 7th sublevels would be. So for our purposes, we only need to know that for 5, 6, and 7, that there can only be an S, P, D, and F for those energy levels.